your homework assignment. Okay? And I want to try to describe exactly what you need to do for this. I'm going to read through this very quickly. It may not make a ton of sense, and I'm going to try to walk you through exactly what you do and what you have to turn in to me. So, in this assignment, your job is to develop a method to estimate the total number of AP statistics books or any other textbook at our school, based on a random sample of books and the assumption that the books are numbered sequentially starting from 1. So the assumption here is that if I pick up a statistics textbook and open it up, that the number inside the textbook would be 1 or 50 or 60. Now they're not necessarily numbered that way, but I'm sure the little barcode in the back, because the way they are numbered is actually down here, the accession number, it's down at the very bottom of your book. I'm sure those go in some numerical order. Okay, so we're just assuming that this would be 1, and Carly, your book would have 2 in it, and Pablo, your book would have 3, and the last book would have, say, whatever, 210. So if the last book had 210, how many books are there? 210. So N would be 210. Now you're trying to figure out that N is 210. You're trying to figure out that there are 210 textbooks, or there's 300 textbooks, or there's 106 statistics books. The thing is, you don't know it, right? You don't know it when we do what's called the competition, okay? So, for example, suppose that a random sample of 7 books, so I go throughout this school and I just look inside 7 people's books, and I write down the textbook number that they had. And so those 7 people had 10, 38, 59, 61, 74, 90, and 94 in their books. So, do you suppose that the total number of textbooks is bigger than 94? More than 94? Or do you suppose 94 is the biggest number that there is? Do you suppose there's 94 textbooks based on this sample? What? You're guessing. I would guess there's more too. I'm guessing that I wouldn't happen to grab the last one in my first sample. Okay? So the question is, how can I use this information to estimate the total number of books? Okay? They're giving me an example here. One possible method would be to take the median value and double it. In this example, the median times 2 is 61 times 2, or 122. So if I use this to estimate the total number, I would be estimating that there are 122 textbooks. So our estimate for the total number of books is N equals 122. Okay, so for this activity, you're going to create 3 statistics to estimate the total number of books. These have to be made up. These are brand new statistics. Okay, you can use, remember, a statistic is any quantity computed from the values in a sample. You may use any combination of the summary statistics we already know, the mean, the median, the min, the max, the quartiles, the IQR, the standard deviation. But here's the deal. You can't just use the IQR. Your statistic can't just be the IQR. It can't just be the mean. Okay? You have to make up a new statistic to help us calculate the correct number of textbooks. You have to, invent your own. That's what I'm asking you to do. The goal is to find a relatively simple statistic that reliably predicts the total number of books. Okay? This problem is actually based on something called the German tank problem. In World War II, I believe, we defeated the Germans in part because of mathematics. Because the Germans numbered their tanks sequentially. Okay? They numbered their tanks in order. And we captured some tanks. And we looked at the serial number on those tanks. And some people got curious and said, well, we know the serial number on these, and I bet they number them sequentially as they make them. So if we can take the numbers of the tanks that we have, which is kind of like the numbers of the textbooks that you're getting, and we try to come up with a statistic or a way to calculate or estimate the total number of tanks they've made based on the ones we've captured, then we'll know how many tanks they have approximately. And what they actually did was they made up their own statistic, and they actually calculated the number of tanks the German army had within one tank. and it was a lot less. What they figured based on this method was actually a lot less than what was actually what they thought. That they thought the Germans had thousands of tanks, and this method gave them a relatively small number. And it turns out that they were actually fairly close. They were within, I think, 1 or 2 of the actual number of tanks that the Germans had, and it allowed them to capture more tanks. So this is based on that, called the German tank problem. You could Google search that and it might help you with this a little bit. So for this activity you need to create 3 brand new statistics to estimate the total number of books. Okay, so to determine which of your 3 statistics gives the best predictions. Okay, so you're going to make up 3 statistics and then you're going to test these 3 statistics. Okay, you're making up 3 statistics to estimate the total number of books there are. Now, to determine which is the best, we're going to do kind of like we did back on this page. We're going to create sampling distributions for our statistics. Okay, so this is how we're going to test. So this is how we test our made-up statistics. How we test our made-up stats. To test your made-up statistic, you want to know whether it works or not. So you actually have to fix or decide what n is to start with. Okay? So to determine which of your 3 statistics gives the best predictions, you'll perform a simulation to generate sampling distributions for each of your 3 statistics. For the purposes of the simulation, you assume that there are 100 books. You assume there are 100 books. That doesn't mean there are. But we need to know what n is. We need to know that there are 100. We need to decide upon a total number in order to test something. Okay? So, and you'll be taking samples of size 7. So here's what we're going to do. Back up here. Let's compare this to what we did over here. What was n here? How many people were we picking from? How many people were we picking from? 5. So n was 5, and we took samples of size 3. Okay? So here, n is 100, and we take samples of size 7. Now, we can't possibly take every sample of size 7 because there's a lot. So it says do 25. So we want to get 25 samples of size 7 for every one of our 3 made-up statistics. And then we compute the value of each of your 3 statistics for the 25 samples. So here's what you need to turn in. And then I'm going to walk through an example. I'm just going to walk through an example at the end of this. So here's what you have to turn in. And you can work with a partner. Okay? You can work with a partner, and then each of you have to do 13 samples. So you would have 26 total samples to turn in. So you can work with a partner. Work with a partner. Each do 13 samples. Okay, so is it better to work with a partner or by yourself? Partner. Okay, but sometimes it's hard because you won't get together. Okay, or maybe you just split, but you have to do 25 on your own or 13 each with a partner. Okay, so what you need to turn in an introduction describing the choice of your 3 statistics. So you need to introduce, you need to tell me, here are my 3 statistics. Make them up. Okay, twice, you can't use twice the median. You can't use anything I use in an example here. So here are my 3 statistics. Twice the median, the max plus the min divided by the standard deviation. And here's my other statistic, twice the IQR plus the standard deviation. So those are my 3 made-up statistics. Why did I pick them? I don't know. I mean, I might want to do, I might want to research a little bit more. What statistic predicts how many values there are? So I just made up 3 statistics. So an introduction describing the choice of your choice of the 3 statistics. Okay. So I make up the 3 statistics. Okay. And I describe maybe why I picked them. Again, you're trying to estimate how many books there are. So you're trying to estimate the maximum. Okay? You are basically trying to estimate the maximum, aren't you? Aren't you trying to estimate that there's 100 textbooks? Isn't 100 the max value? So I'm trying to estimate the maximum. So you have to kind of explore what would give me the maximum value. What would give me close to 100? So I'm just guessing at 3 statistics here. You could research. How do I estimate the max value of a sample? Okay? So you need to give me an introduction. This is between you and your partner. It can be handwritten or typed. 3 dot plots showing the sampling distributions of each of your statistics. So the 3 dot plots, they should look like this, but each dot plot should have 25 dots on it, because you're going to do 25 samples. Okay? Yes, Pablo?
Do you choose a different 25 for each sample?
You could do the same 25 for each one. Because you could, for each statistic, you could just get 25 samples. Can't you just calculate 3 different statistics based on those 25 samples? Yeah, so yes, you only need 25 samples. You can do the 3 different statistics, okay? Now, so 3 dot plots, make sure that they are on the same scale so that they're easily compared. So this will get a dot plot with 25 dots on it, so you calculated, and I'll walk through a full example here. This one gets a dot plot and this one gets a dot plot. And then basically you're looking for which one, what are we assuming is the maximum in our problem? What are we assuming the maximum is? 100. So you want to basically see which of these gets closest to 100. Which of these gets on their dot plot closest to 100, right? So in which of these are most of the dots closest to 100? So you want a small range and closest to 100 as far as, and that'll be your best statistic. So then a description of which statistic you think is best and why. Okay? So this is due Friday, January, today's the 19th. What's Friday going to be? The 23rd? Friday the 23rd, this is due Friday, January 23rd. 1 per group. You can work on it separately. You know, maybe you each make up a statistic on your own and do 25 of that, and then the third one you do together. Okay? Yes, Pablo?
So what are we collecting?
What do you mean?
Are we supposed to actually look at books?
No. I'll show you in just a minute exactly how you do it, because you're going to do it all on your calculator. You're going to simulate. I said you do a simulation. You simulate collecting things. So note, next week in class we're going to do a competition based on your best statistic, and they'll be worth extra credit points. So here's exactly what I'm going to do, Pablo. Here's for an example, okay? So I have my 3 made-up statistics here. I'm going to write them on this page. This is exactly what you do. So I've got my 3 statistics. I've got twice the median. I've got the max plus the min divided by the standard deviation. And I've got twice the IQR plus the standard deviation. Okay? I'm making a video of this. So what I'm going to do is I'm going to generate 25 samples of size 7. 25 samples of size 7. I may not get all of them. And so basically what I'm picking, I need to do math, PRB. I'm going to basically generate 25 samples of size 7. What does that mean? I want 25 sets of 7 numbers from 1 to 100. So basically, if I'm simulating going around asking 7 people what book number they have. So I'm going to go to math. Okay, go to math. Go over to PRB, and I want to do random integer, and then 1, 100, 7. That's what I'm going to do every time. Hit enter, and that's going to give me 7 numbers, 7 textbook numbers from 1 to 100. And if I go hit the over arrow, oh, see here, why is this one bad? I got 212. So I eliminate that one. I just have to hit enter again. And I got 13, 54, 24, 9, 46, 25, 94. So is that a good one? Are there any repeats there?